So the 100 gig ZR family of products is really unique in the market. It enables IP over DWDM applications to be realized using 100 gig routers and switches. So IP over DWDM results in smaller footprint, smaller power dissipation. So it saves on cost, it saves on power dissipation, it saves on footprint.
Hi, my name is Ciara McCarthy and I'm the Chief Marketing Officer at EPS Global. Today we're diving into the world of optical networking with John Lynch, VP of Sales for EMEA at EPS Global, and Kevin Affolter from Coherent. Kevin is a product line manager for 100 gig ZR DCO, and he's here today to talk about his latest product. Let's jump right in. Can you introduce yourself, please, John? And then I'm going to hand over to you so you can grill Kevin on the technical aspects of the 100 gig ZR DCO optical transceivers.
Thanks, Ciara. I'm John Lynch, and I am the VP of Sales for EMEA for EPS Global. EPS is an Irish-owned company. We are headquartered in Dublin. We're here since 1999, and we are Coherent's largest global distributor in their network today. So Kevin, very nice to see you again. We're here to talk about Coherent's 100 gig ZR optic. We have heard a lot about this product from you guys over the last year. Can you tell us a little bit about what is the big advantage for customers in the market who want to use this product?
Sure. Thanks, John. So the 100 gig ZR family of products is really unique in the market. It enables IP over DWDM applications to be realized using 100 gig routers and switches. If, in case you don't know what IP over DWDM is, essentially it means plugging the colored optics directly into those switches and routers. So IP over DWDM results in smaller footprint, smaller power dissipation, because you're able to remove the transport equipment that would typically have been in the network, and also the short reach optics. So it saves on cost, it saves on power dissipation, it saves on footprint, and all of which result in lower cost. It also, there's less equipment in the network, so it improves network reliability as well. The product family that we developed, it was really enabled by being able to co-develop our optics with our in-house Coherent DSP capability, so that we were able to drive the most efficient solution possible.
Right. And Kevin, we've been selling optics now from Coherent and previously Finisar for about 25 years. And we're used to these products being commodity items, that most of these products will have 5 or sometimes maybe even 10 vendors who support the same product. But this part that you have just released is pretty unique. So what is it about this part that makes it special in the market?
I think the key thing is that it is the form factor. So it's in a QSFP28 form factor, which is there's a lot of QSFP28 form factor around, typically a little older, but this is the first time a Coherent solution has been available in that form factor, so that then enables this IP over DWDM for 100 gig switches and routers. But all of that is enabled by being able to drive down the power dissipation of the module. So getting that down to 5 watts is really a Herculean effort to do that. So that's the big piece, getting the power dissipation down really low, and that was enabled by doing our own design for purpose DSP and our own optics.
And can you tell us a little bit about the development of the part, Kevin? So it has a unique DSP. How did that affect the development of the part compared to other parts that you develop all the time?
So we developed the DSP with our own team. Obviously, we partnered with fabs external to the company, but this allowed us to really focus on just a few applications, and then strip out anything from the DSP that was not needed. So typically, if you're working with a commercial DSP partner, because the investments are so huge, they tend to throw a lot of bells and whistles in, because they're trying to address as broad a customer base as possible. In our case, the application space was pretty narrow, and by constraining it to those few applications, that was what really allowed us to get the power down and also keep it small, right? The less features that you have, the less silicon real estate you use, the less power you consume. So that's all part of the mix.
Right. So the DSP has been designed specifically to require less power than regular parts. So
yeah.
How much power do your parts typically consume?
So it depends a little bit on which part, but the -8 dBm part, which is set up for the commercial operating temperature range, which is 0 to 70, that consumes, worst case, end of life, 5.5 watts. Typically, though, the power dissipation is going to be more in the range of 4.5 watts.
Right. And just for the audience, Kevin, how does that 4.5 watts compare to similar products with a different form factor that might be using an off-the-shelf DSP?
So there's a couple of things that spring to mind there. One would be, you could use a 400 gig ZR type product or ZR plus type product. That comes in a bigger form factor, so it's a QSFP DD. So it's a bit bigger, and it's bigger because it consumes more power. So typically that's going to be more than double the amount of power that we're consuming in our module. Another possibility would be the CFP2 form factor, which is more of a kind of a historical form factor for 100 gig solutions, and there the power is probably 3 or 4x, and it doesn't plug into a router or switch. It's a much bigger form factor, so it fundamentally doesn't enable IP over DWDM. So those savings I was talking about earlier are not realized.
Okay, great. So we've talked a little bit about what you've done with the DSP, and we quickly mentioned the form factor. We have seen 100 gig optics in several different form factors. They're still out there in the market. Can you talk about, I know you've chosen QSFP28. Can you talk about why you've chosen QSFP28?
Yeah, I think it is a couple of factors, I would say, but the big one is just knowing that there are a lot of 100 gig ports in switches and routers that are already deployed, in applications, not IP over DWDM applications, but they're already deployed. They've shipped in, I don't know, millions and millions of units. So there's a lot of ports out there. So the overall market opportunity for this is actually huge. And then that coupled with really some guidance from network equipment companies as well, that were looking for more dense, lower power dissipation solutions at 100 gig. So that all led us to the QSFP28 form factor.
Super. And Kevin, once a customer decides that they're interested in this part, that it suits their application, how do they decide which version best suits their needs? So I understand there are two versions, a high power version and a standard version. Can you talk to us a little bit about what the high power version can do for you, and then a scenario in which a standard version will be sufficient for your needs?
So both of those versions of the product are available in C-temp or I-temp mode. So they can support 0 to 70 degrees C application, or also an outdoor application, going up to plus 85 down to minus 40 degrees C. So the minus 8 dBm or standard power product, that's intended for ZR applications. So that can be non-amplified, in which case it could go up to an 80 kilometer reach, or amplified, which would get us up to about 120 kilometers reach. Those are typically pretty simple point-to-point networks. Today you might have customers that are deploying ZR4, which is another way of satisfying the same link, but you can only have one of those on your fiber. In this case, you could have 96 of them on the same fiber. The 0 dBm product, though, that's intended more for metro regional networks that are typically ROADM based, so reconfigurable optical add drop multiplexer based. And the higher power there is required to be consistent with the power levels in those networks. We also have a version of the 0 dBm product that has a tunable optical filter as well, and that's on the transmit side, and that's to clean up any out of band noise in the optical spectrum. And this is targeted for a specific application, which is a colorless ROADM network. This is where the ROADMs are based more on couplers and splitters rather than filters. So there's no filtration in the ROADM.
Thank you. And if we assume good quality fiber interconnects, Kevin, what kind of distances can customers expect to reasonably achieve using the higher power part, the 0 dBm part?
So both the high power and the standard power parts, they both have the same chromatic dispersion compensation capability, and as a standard, that is 120 kilometers of reach, but they also both have a configurability that's built into the part that will enable you to turn on a little bit of extra chromatic dispersion compensation, and that'll take you up to 300 kilometers as a spec. In reality, we've done demonstrations in our own labs and even in places like OFC over 400 kilometers. Now, but that's talking about the chromatic dispersion tolerance. But from a loss budget perspective, the standard device has a loss budget of 22 dB. And the high power device has a loss budget of 30 dB.
Right, thank you very much. I don't know if you're allowed to talk, Kevin, about any specific customers, but are you able to share any interesting use cases where these 100 gig ZR optics can solve particular networking challenges?
Yeah, so I think the big one, I hinted at it a little bit earlier, but the big one is where customers are, they have a 100 gig router or switch, and they're using it using it with short reach optics. They're coming out of the switch, they're going into a transport box, which would be a transponder or a muxponder. And then they're going over the line system, and then they have the same on the other end. Another transponder, muxponder, short reach optics, and into the router on the other end. By moving over to these 100 gig coherent optics, you're able to remove that transport equipment, so the transponder or muxponder goes away. You leave the line system that's there. but you get rid of the muxponder and you get rid of the short reach optics. So that then means you have less network elements, so fewer network elements in your network. That's less things to go wrong. There's also power dissipation associated with those, and there's footprint associated with those. So those are all things that cost service providers real money.
Right. I've heard you talk, Kevin, previously about customers who have existing 10 gig DWDM networks who, because of all the content that we use today, have a need to upgrade those networks to 100 gig. So this is a really interesting application for this part as well.
Yes, and that's thank you for the reminder. But yeah, absolutely. So we have customers who are, they're using 10 gig DWDM, so 10 gig tunable parts today, and they've already deployed the 40 wavelengths that they're allowed to deploy, or the 80 wavelengths, whatever the number is. So they filled up the C band, and they need to, they don't want to purchase or lease any new fiber, so they can reuse the line system, so the optical fiber, the amplifiers, the muxes and demuxes, and they can take away the 10 gig routers and switches that they're using and replace those with 100 gig, and they get a 10x increase on the capacity on that fiber. So it's a big part of their capacity expansion play.
Right. So these are brand new parts that you've developed, but you don't necessarily need brand new equipment to use these parts.
Correct. Yeah. The line system could stay exactly the same.
Right. And we've been used to this SFF interface, Kevin, for QSFP form factor for years. But Coherent have made this part available with two interface versions, SFF and CMOS. Why did you do this? And are you able to talk to us a little bit about the difference between the two interfaces?
Yeah, so the SFF 8636 standard was written many years ago. I think there's been a bunch of revisions over the years, but it has there are some limitations in terms of its functionality. And I'll give just one example of that. There are many, but so it doesn't support wavelength tunability. So you're not within a box that is SFF 8636 compliant. There's no command to change the wavelength of the module. Here we're talking about tunable modules, right? So this is absolutely a limitation. CMOS offers many more features, and including the one we were just talking about. So within the CMOS management interface, you can change the wavelength of the channel of the module. So typically, the CMOS products are going to end up being used by network equipment manufacturers, and they may be sold as part of a system solution. The SFF 8636 part, that's really more intended for legacy routers and switches, that are already deployed in the field, where the service provider is looking to either eliminate the equipment, as we talked about before, the transponder, muxponder equipment, or increase the reach, or increase the capacity, or some combination of all of those.
And Kevin, vendors developing new platforms today, why do they develop those platforms with CMOS interfaces rather than SFF interfaces?
Really, so that they have this, they're able to access this extra functionality. So the ability to tune the wavelength, the ability to choose between gigabit Ethernet and OTN. So that those are features that are offered by CMOS that are not offered by SFF.
Right. And I understand you have a version in the range with a tunable optical filter integrated into the part. why would a customer need this version of the part? What does a tunable optical filter do for the customer?
So the TOF or tunable optical filter is it's used to suppress the out of band noise in the optical spectrum coming out of the laser, so the laser has if you look at the spectrum of the laser, it has kind of a floor, and then it has a peak at the lasing wavelength. So what it does is it suppresses all of that floor to much lower levels. And that's important for colorless ROADM applications, so unfiltered ROADM applications. But it's really not necessary if you have a colored ROADM application. Really just needed for those colorless applications. But there are people that do have colorless ROADMs deployed, and so super important for those folks.
And for customers in exotic locations, Kevin, who might need to deploy these parts in extreme environments, very hot or very cold, have you got something for them that will work?
Yeah, I think we've got something that'll work for people in Dublin, those extreme environments. We have iTemp versions available also. So these will operate from minus 40 C to plus 85 C. And typically that's for an outside plant application, like a street cabinet or on top of a pole. So those kinds of applications.
So we can see that these parts are a really good fit for a customer who has an existing DWDM line system and they want to upgrade from 10 gig to 100 gig. What about somebody who wants to use a ROADM system, or someone who already has an existing ROADM system? For our less technical viewers, can you explain to us briefly the difference between those two types of systems?
Yeah, so a point-to-point network is pretty simple. It's just a straight shot between two locations, at least conceptually. This would be representative of kind of like the 10 gig to 100 gig upgrade that I mentioned earlier. A ROADM network is more complicated. It allows traffic to be added dynamically and reconfigured at multiple points within the network. You can almost think of a ROADM network as like a road network. So you have your highways and your on ramps and your off ramps, and it's a very, very similar kind of concept.
Right. And again, Kevin, for the benefit of our audience, can you just explain the difference between, you refer to a colorless ROADM system and a standard ROADM system? Can you just give us a quick explainer of the difference between those two ROADM systems?
Yeah, really. We have parts that will work in both of those. The one with the tunable optical filter would be used in those colorless ROADM applications. The main difference is the in an unfiltered ROADM scenario, or colorless ROADM, there is no filtration provided by the ROADM, versus a colored one where there is filtration provided, and that's why we add the tunable optical filter to the module, so that it does that filtration to clean up the spectrum and just help the overall system performance.
Right. And Kevin, for probably the first time in human history, the whole world has been talking about tariffs for the last couple of weeks. Everybody is suddenly paying a lot of attention to where things are made. Are you able to tell us where Coherent are manufacturing these parts?
Yes, absolutely. So we have two manufacturing locations for the modules. We're currently building in both in Wuxi in China, but also in Ipoh, Malaysia. So the products can come from either of those locations.
Excellent. So customers have some flexibility about which factory they can use, and I think you guys enable that through a part number chain where a customer can order a -1Y from Malaysia or no suffix for China. So there's total flexibility for the customer in terms of where they source that part.
Yeah, correct. And it just makes sense for us to, especially with the tariff situation, but even before that, just having geographical diversity in our supply chain makes a lot of sense. So yeah.
Thank you. And Kevin, finally, I guess the bit that customers are very interested in always is about the price of these solutions. Are you able to talk to us a little bit about the cost benefits of using this 100 gig device versus the solutions that are already out there in the market?
Yeah, so I think if we think back to those two applications that we talked about, so in the case where you have a 10 gig DWDM, let's say point-to-point network, you're out of capacity. How do you add more capacity? Well, you either have to light up another fiber, which means either laying another fiber or leasing another fiber, which is expensive, or you use the same fiber, same amplifiers, same muxes and demuxes that are already deployed, and you take out your 10 gig and you put your 100 gig in. So you've increased the capacity on your fiber by a factor of 10. That's huge, and you haven't had to lay another fiber. So that's first example, I would say, where it's an incredibly cost-effective way to upgrade the capacity on an existing network. The other is really the IP over DWDM example, where you have a customer who has a router at either end of the network. They have the gray optics, and then they have the transponder or muxponder solutions, which is what's carrying the DWDM part of the traffic. And by being able to eliminate those transponders, muxponders, and the short reach optics that go in between them, they save a significant amount of money in terms of footprint in a central office costs you money. It costs you that extra equipment costs you electricity, and you have less. By removing those, you have less network elements in your network, so the reliability of your network improves. So there's multiple benefits, all of which have a dollar impact to the end, to the service provider in this case.
Kevin and John, this has been incredibly informative. The product looks really interesting, and the fact that you've a ready-made install base out there already that can retrofit the parts into the existing networks makes it very exciting from a commercial point of view. Thanks, Kevin, for sharing your knowledge with us. I'm definitely glad I let John ask you the hard questions. But before we wrap up, John, I just wanted to ask you, for network operators who are interested in evaluating these optics for their environments, what resources does EPS Global and Coherent provide to help them determine if this is the right solution, or what's the best way for them to get started?
Yeah, Ciara, so we're already working with a whole pile of customers all over Europe with these parts. So typically we've been working with them by providing them with proof of concept samples. So we're sending out samples to customers. We're letting them plug them into different platforms that they want to test them in. We're helping them with any technical support that they need. In some cases, we're bringing parts back and changing some settings if that's what they need. And ultimately, it's a try and buy system. Our customers can test these parts. And so far, everyone who's tested the parts has bought them and has gone ahead and placed some orders. So, the reaction to these parts so far has been very positive, and we're just trying to get as many parts into customers' hands as we can so they can try them themselves and form their own opinion. And we have stock in place in our locations in Dublin and in the US and in China. So any customers around the world who want to try out these parts, we're happy to help them, and we're happy to lend them the parts to see what they think of them. And if they don't like them, they can send them back. So for any customers who want to test these parts, we're working hand in glove with Coherent as well on these proof of concept. So if customers need any input from the Coherent engineering teams, we're happy to collaborate side by side with any customers. We have a totally open door there. And if customers want to speak directly to any of the application engineering team in Coherent, we can facilitate that too. So all options are available to any customers who would like to test these parts.
Perfect. Thank you, John. Thank you both again for sharing your expertise with us today. And if any of our listeners would like to learn more or apply for a proof of concept, you can visit epsglobal.com/100G-ZR or visit the link in the description. I look forward to getting back together with you both, John and Kevin, in a couple of quarters to talk about the take-up of 100G ZR in the industry.